All right, so I will try my best to finish chapter 7 today. I don't think we're going to do that, unfortunately, because of the quiz. I don't have less time, but I'll do my best and see how far we go. We're still a little bit behind. At least I would have liked to be done with chapter 7 by today at the latest, but it may not be the case, unfortunately, because chapter 9, I think, may need a little bit more time than usual, because it's a little bit of a different chapter, and you'll see what I mean when we get to it. So it's the next chapter. We're going to skip 8. We're going to go straight to 9. All right. So let's pick up where we left off last time. And so we were talking about this slide and sort of setting the scene for this internal rate of return criterion. And so we talked about two cases. One is where we have a single project, and then we have two types of investments: simple, where there is one sign change in the cash flow, and non-simple, where there's more than one sign change. And we said when the investment is simple, we have a unique rate of return, right? And the decision criterion, we know that from chapter 5, we can accept the investment if I star, which is the internal rate of return, is bigger than the MAR. Again, remember, I'm going to show you the graph on the next slide, so I won't waste time drawing it here. If we have a non-simple investment, generally we're going to have multiple roots, multiple I star values, right? Because the graphs looked kind of funny. Sometimes they look like this, maybe. I ran out of space, but you see here already we have 2 zeros. And so in that case, what we need to do is either use chapter 7a, which we're not going to go through, or we just go back to our old friend, the net present worth criterion, because that's easy to do, right? I just compare the net present worth at the value, at the MAR value that I'm given, and then I select the one with the higher. Sorry, this is a single project, so you just accept if it's positive. You reject if it's negative, and you're indifferent if it's 0. What about if you have multiple alternatives? If you have mutually exclusive projects, we're going to use something called incremental analysis, right? And in this case, we're going to have to do something. There's an additional step that we do, which is we do this B minus A. So we take the cash flow of A and subtract it from the cash flow of B, and then we compute. Then basically we do our criterion on this B minus A investment. Okay, we're going to see what that means and why we need to do that later on. But then the criterion becomes, if this I star for this new B minus A investment is greater than the MAR, I will select B. If it's the opposite, if it's less than the MAR, I will select A. And we're going to see this in more detail later. Okay? So this is kind of a summary of what we're going to do for the remainder of the chapter. Again, for simple investments, we have a unique rate of return. So the internal rate of return is equal to whatever root that we find from the expression, from this expression here. And our criterion, as before, is, again, if the IRR is greater than the MAR, we accept. If it's equal, we're indifferent. If it's less than, we reject. So this is chapter 5 stuff. If you have a non-simple investment, again, we've seen that in the flow chart just now. Of course, we have multiple I star values, right? So we don't have an internal rate of return per se, or it's difficult maybe to find or to determine which rate of return we need to use. And so in that case, we use appendix or chapter 7a, which comes right after chapter 7, not at the end of the book. This is right after chapter 7. I think before the questions, or maybe right after the questions, if you're interested. Or we can just abandon this IRR approach and just go back to the net present worth approach, or even the AE approach if you want to. Okay? So let's see examples. Now in this example, actually, we have a non-simple investment. And so let's see what this is. So this is some company that is approached by the US government to build Navy flight simulators, okay, to train pilots. So this is the government asking for a project from a company, from a private company. Yeah. And they're telling you some details. For some defense contracts, the US government makes an advance payment when the contract is signed, whatever. In this case, the government makes 2 payments. So as far as the company is concerned, this is the first inflow from the government, right? So this is, again, from the company's perspective. It's going to get money from the government at the end of the first year, right? And then it's going to get $3 million at the end of the second year. And then what else do we need to know? The expected cash outflows, right? So the amount that the company needs to pay in order to build or produce these simulators are estimated to be $1 million during the $1 million now, $2 million during the first year, and $4.32 million during the second year. And so this is basically the cash flow given in this table, right? So the inflow, the income that you're getting from the government, years 1 and 2, and then you have the outflows, which the company, these are the costs that the company needs to pay. And of course, we know that we can compute a net cash inflow just by subtracting the outflows from the inflows. And so, of course, the first thing you notice if you look at this net cash inflow is that this is non-simple because we change from negative to positive back to negative. Okay, and I'm asking you to compute the values of I stars, so to find basically the roots of the polynomial, and then also to accept or reject the decision on the basis of whatever you found in part A, assuming that the MAR is 15%. Okay, so of course, from what we've seen before, we know that non-simple investments, we have to first check if they have multiple roots. And here the question is kind of hinting at that. It is possible, again, for a non-simple investment to have a single root, in which case we can use the criterion for the single investment if we want to. But sometimes it will have multiple roots, and in that case, we need to do something different. So first of all, we could draw the cash flow. It looks a little bit weird. It looks kind of funny. So this is the net cash flow, by the way, and that's why, this is just the last column in the table. So minus 1 million, and then plus 2.3 million, and then minus 1.32 million. The MAR is 15%. Okay. Now, ideally, you would draw this just to make sure, again, that you have that you have multiple roots. I think in this case they don't draw it, or they do, but at the end. And so I would prefer that maybe you draw it, or maybe because in this case the question tells you that you need to find the value of the I stars. It's kind of suggesting that there are multiple I star values. But it may be tricking you sometimes. But in any case, let's just go through the book solution. In order to find the rate of return, again, I need to solve the equation that says the present worth of I, or I star, is equal to 0. And I need to solve for this value of I, right? And so I write down the expression for the present value, moving everything to times 0, and I set it to be equal to 0. Now, again, from what we've seen before, you can do the substitution that we did before to convert this into a nice polynomial that you can handle using the quadratic equation, right? And so I make the substitution x is equal to 1 over 1 plus I. And if I do that here, right, this is the substitution. And we did this before, right? We get x and x squared. And so now this is a very nice polynomial, and I can use the quadratic formula to find the roots, right, to solve for x in this case. And if I do that, I get 2 possible values of x, right? I still need to go back and solve for y by going back to this substitution expression here. And so I do that, and I find that either I is equal to 10% or I is equal to 20%. Okay, so now here notice that I have, this kind of tells you also that you have 2 roots, because neither of them was, they're both basically in the range, so I'll write it here, in the range of minus 100% to infinity, right? So both are acceptable interest rates. We know that MAR is 15%, and so now, of course, because we have 2 interest rates, it's not clear what we should do, at least, based on the criterion that we have, like when we say, because notice that the MAR is sandwiched in between the 2 interest rates. So do I accept, do I reject? And we said in this case, we either have to go to chapter 7a, right? Or, because we're not going to cover that chapter, you go back to the net present worth approach, right? And so you evaluate the net present worth at the MAR, and then you see if it's positive or negative or 0. And so you kind of ignore this approach here because you have 2 roots. Again, you can see this by drawing, or you can see it from here because we have 2 acceptable roots for this polynomial. And so if you go back to the net present worth approach, right, I evaluate my net present worth at the MAR, which is 15%, and I get this value here. Notice that this is positive, therefore I accept the investment. Okay? And here you can see the graph that I was talking about for this investment, right? It crosses the x-axis at 10% and at 20%, right? This axis is I, right, interest rate. And so you see here it crosses twice. And what we did basically is we looked at the MAR, the present worth at the MAR, which is 15%, which is here. I evaluated it. I saw that it was positive. I accepted. Okay? So the only reason I needed to do this step here to solve this business is to figure out if there are actually two roots, which turns out to be the case. So you can sometimes figure this out by drawing the function if you can, if it's easy to draw, and maybe that will make life easier for you, especially if you have software that can draw the function without a lot of issues. So again, because the present worth at the mar is positive, then we accept. All right, so this is as far as single investments are concerned. We've already seen how to make decisions when we have a simple investment, and also when we have a non-simple investment, when we have single projects. And so now let's turn our attention to the other half of the flowchart, which is about comparing mutually exclusive alternatives. So the case here, again, is that you have multiple projects. You have 2, 3, 4 projects that you're trying to compare. And we're trying to use this IRR approach to see if we can do that. Now, there is actually an issue here. And so the issue is highlighted by this example. And so the question here, is being posed, can I rank the projects based on the magnitude of their IRR values? What does that mean? Well, assume I have these two investments here, these two cash flows, okay, A and B. These are simple. These are very simple cash flows, right? As simple as you can get. So at time 0, you make an investment, and then you get a return at time 1, and same thing for B, but with different amounts. Now, if I compute the rate of return for this investment, in this case, it's very obvious. Like, you don't even need to use your F given P formula. You can do that, of course, and solve for I. But in this case, because you make an investment of 1,000 and you get 2,000 the time period after, you're essentially doubling your investment, right? So your rate of return is 100%. And in this case, also, you can see it if you divide 7,000 by 5,000, you'll get 1.4, and therefore you made an extra 40% on your principal, and so the rate of return is 40%. But here, I think they use the F given P formula. You don't really need to, but you can do that. It will give you the same answer, right? So by F given P, it's really this 1 plus I to the 1, because we only have one time period, right? And then you solve for I, and you can see here if you solve for I, it will just be F divided by P minus 1. And that's how you get 100% and 40%. Okay, so these are the rates of returns for these two projects. Now the question is as follows. Can I just decide that project A is a better project because it has a higher rate of return? Is that consistent with the present worth approach? And so let's find out. Okay, so obviously, this number is higher, so I'm getting a much higher return rate in project A. Is that enough? And well, to answer that, we need to look at the present worth of both investments and see if it's also consistent. Meaning, is the present worth of project A also greater than the present worth of project B? Then maybe this is enough. Maybe this is consistent. If we do that, so this part of the table is from before. I've added the present worth at 10%. Right? This is my mar. I'm using 10% as my mar. Look what happens. The present worth of the investment in project A is $818. It is actually less than the present worth of that of project, well, B or A2. I'm not being consistent here. I'm not sure why I used A and B here, but A1 and A2 here. Whatever. It's the same investment. All right. So this rate of return is higher, but the present worth actually goes in the opposite direction. Okay. So actually, you cannot just make comparisons just by comparing the value of this percentage. You can't just look at the internal rates of return and pick the one that's higher. Okay. And let's see why, right? Let's go maybe in a little bit more detail on this example just to understand maybe what's happening. Just to give you like a hint first, the present worth considers absolute values of dollars. When I say absolute values, I don't mean mathematical absolute. Much I invested, right? I can have two investments, one where I invest minus $1,000, right? I invest $1,000. Another one where I invest minus $5,000. If they both give me a rate of return of 100%, if I just compare them based on the value, so assume this is 100% as well, I'm going to conclude that they're equal. But of course, if I invest 5,000 and I get 5,000 in return, I'm getting a lot more money, right? So one weakness of this IRR comparison is that it does not take into account the magnitude or the scale of your investment. You can think about it. You can make a very contrived example. Like suppose I get a 100% rate of return, but I only invest $1, right? So I invest $1, I get another dollar. That's 100%, but I'm only investing $1. Compared to this case where I'm investing $5,000, and let's suppose I'm back to the original 40%. Now, obviously, this one is really better, right? I mean, I'm getting a lot more money, but this is not captured by these percentages, okay? So that's kind of the issue that's going on here. And that's why we need to use something called incremental analysis. And you guys saw from the flowchart, we needed to find something that relates to B minus A. And we'll see why that is the case. Okay, so here we have our same two projects again. We have the rates of return, and then we have our present worths. Now let's think about what happens in project A, going back to our concept of the investment pool in chapter 5. Right, so we had an investment pool. And assume that this investment pool has $5,000 in it. Okay, why did I pick 5,000? Because project A2 has 5,000. Okay, and we'll see why. I mean, I'm telling you why now, but we'll see like really why this is the case. In project A1, what's going to happen? Well, I'm going to take $1,000 out of this investment pool, and I'm going to put it in this project, right? So this is going to go here in this project, this $1,000 amount. From this $1,000, I'm going to get $2,000 back, right, in year 1. But also consider what's happening to the remaining $4,000 that are sitting in the investment pool. Remember what we said about the investment pool? Anything that's in the investment pool earns interest at a rate of MAR, right? And so the MAR here is 10%. So the $4,000 that's sitting here that I chose not to invest is earning interest at a rate of 10%. Now, if you see here what's written, I mean, this is just describing what's happening. So for project A1, I need $1,000 from the investment pool, right? The remaining $4,000 is going to continue to earn 10% interest at the MAR. What's going to happen 1 year later? From the $1,000, you're going to get $2,000. From the $4,000, it's earning, so remember, like here, the interest rate is 100%. Here, it's only 10%. So from the $4,000, you're going to earn $4,000. Well, you're going to get $400 additional dollars, right? And so you're going to get $4,400 from the money that is sitting in the investment pool. And so the total that you're going to earn in year 1 is really this much, which if you compare it to the $5,000 is a 28% return. Okay. Now, if you find the present worth, you get, of course, what, I mean, you can just compute the present worth at 10% of this project here. And you see that it is $818. You could do this from two perspectives. If I'm like, you can see here that you're investing 5,000, right? And then you're getting 600 and you're getting 6,400 because it is 4,400 plus the additional 2,000, right? If you move that back to 10%, you get 818. Or you can see if you do it from here, it's kind of the same thing, right? If you move this back using this interest rate, you will get the same value. Sorry, not using this interest rate, using the 10% also. You'll get that 818. Why is this the case? Because remember, we had two perspectives, like when we computed the net present worth, if you guys remember from the investment pool concept that we covered in chapter 5, this is kind of exactly what's happening, right? We take money from the investment pool, we put it in an investment, and then the remaining part earns interest at the MAR. But if you compute the present value of the total, it gives us the same thing as the present value of the project at the MAR. And you can do the same thing for project 2, right? However, notice that for project 2, what's happening is that you're investing the complete investment pool, right? So it's just the $5,000 that's completely invested in project A2, and it's going to generate $7,000 after 1 year. And this is its present worth at 10%, at the MAR rate of 10%. Okay, so this is kind of the picture, right? If going back to the investment pool concept. Okay, now let's answer the question why we need to do this incremental business. And let's see, first of all, what that incremental analysis means, and then we're going to see why we need to do that. So here you see the two projects. Notice I've added a new column, which is the incremental investment A2 minus A1. So first of all, notice again what's happening based on the investment pool concept. So here I have 1,000. The total is 5,000. Really what I'm doing in project A is taking out $1,000 from my investment pool. Project A2 uses the entire investment pool. And so really my question should be, is it worth it to invest this additional $4,000 in project A2? That's kind of what I'm asking here, right? I can go with A1, in which case I only use 1,000, but I'm really asking for a justification for the use of the remaining $4,000 in A2. I need to see if that's worth it for me. And that's why this question, the way I posed it, right, this additional $4,000, this incremental amount, that's why we need to use the incremental investment, this incremental analysis. So what do? I need to find the difference between A2, which is the bigger investment, the costlier investment, and the smaller investment, which is A1 in this case. And you can see here that difference is an additional $4,000, which corresponds to the question that I just posed, right? It's basically asking the question, is the additional $4,000 in investment worth it? I also noticed that it's going to get me an additional $5,000 in return, right? Now, if I look at this investment here, this cash flow, I can compute its rate of return. And that turns out to be 25%. I can compute the present worth also of this investment at 10% at the MAR, and I get this value here. Now, to answer my question, because the present worth of this additional investment is positive, then the additional investment is worth it. Okay, so it is justified because it has a positive present worth value. And so here it is. I mean, here's just the computation of this present worth, right, for this incremental additional investment. And I see because it's positive, again, I'm justified in taking the costlier investment, which actually corresponds to A2. Okay, because the additional 4,000 investment is worth it, therefore I go with the costlier investment, which is A2. This is why we need and how we do incremental analysis. And so maybe here in this table, I have sort of the same values, but here, I mean, everything is written in words. So assuming a MAR of 10%, you can always, of course, earn interest at the MAR, right, by keeping the money in the investment pool. And so you're asking the question, is investing in an additional $4,000 in A2, that will give me an additional $5,000. Is that worth it? Right? And then based on the example, we've seen that it is worth it. And so I will accept this additional investment. And therefore, I will go for the costlier option, which is A2. There was a question, Mazen?
Yes, Doctor, just a quick question. Is the internal rate of return the same as the rate of return ROR?
So in the simple projects, yes. So rate of return is just in general solving this equation here. So it's the I star value. When you have a simple project, you have this relationship. But generally, when you have a non-simple project, you may have multiple rates of return. And therefore, usually we just have one internal rate of return value. So because you have multiple I stars, it's not clear that you have an internal rate of return. So in this case, because obviously this is a simple investment, so yes, the rate of return is equal to the internal rate of return, which I think, yeah, so here I've used ROR, maybe that's where your question comes from, and here I'm using IRR, but they're the same thing.
يعني فالنون سمبل انفستمنت ما نعتبرهم نفس الشيء صح؟
It depends. In some cases, you may get lucky and you have one I star, right? You have one rate of return. In that case, it will be the same. But if you have multiple rates of return, then you need to use chapter 7a maybe to figure out which one is the real one in a way. And so that we're not going to cover.
Okay, thank you very much.
You're welcome. Okay, so let's see some examples. Well, first let me summarize the steps, and then we'll look at examples. So the steps are as follows in order to compare alternatives using incremental analysis. We first need to find the cash flows, of course. Then what I do, like I did in the table, I need to subtract the cash flow of the lower investment from the cash flow of the higher investment. So if the higher investment is B, I need to do B minus A. Again, why is this? Because I'm looking at the additional investment and checking whether or not it's worth it. And by additional, I mean like this has to be the costlier investment. Okay? Then I compute the IRR on this incremental investment. So I compute the IRR for B minus A. And then I can go back, I can use the present worth criterion if I wanted to, like I did in the example or the table that I just showed, or I can go back to my original criterion, but now notice that I use this IRR of B minus A, right? So I look at this incremental investment, look at its rate of return, which is equal to the IRR if it's simple, and then I compare that to the MAR. So if I go back to the table here, I obviously made my justification based on the present worth, but I could also just look at this value here, 25%. That is greater than my MAR of 10%, therefore I accept it. So I mean, these two are consistent with each other, whether or not you use the present worth on the incremental one, or you could just compare it to the MAR, they will give you the same answer. And so that's what I have here. I'm using these criteria here to decide whether or not to accept this incremental investment. Now a note here, make sure so that the IRR of A only when is the one you choose. So before I go back, so notice here that the IRR for the incremental one is greater than the MAR. So which project should I accept? You accept the costlier one, and that is project B in this case. So always if you have B minus A, you accept B, you accept the first one, because it's the costlier one. Because I'm accepting B, I need to also make sure that on its own, let me erase all of this stuff, its rate of return is also greater than the MAR. So not only is this greater than the MAR, but also, assume this is B, I mean, here it's written as A2. But also this is greater than the MAR, so therefore, khalas, I'm done, I can accept, right? I'm actually not sure now that I think about it what happens. I'm guessing if it's, well, I mean, if this is less than the MAR to begin with, you can exclude it completely. I think that's what happens, right? So you can filter out, if you're given 3, 4, 5 options, and immediately you notice that one option has a rate of return that is less than the MAR, you can immediately exclude it from further analysis, okay? That's why I'm adding this step, this check here. So just make sure that individually the projects have a rate of return that is greater than the MAR. Now let's look at examples, and you'll see it's very easy. I mean, hopefully the concept helps you internalize it and remember it, like why we need incremental analysis, but really doing examples is fairly straightforward. So here, John is a college student. He wants to start some business, right? He has 2 mutually exclusive alternatives or options. One is whatever, right? I'm going to call it B1. I mean, you can read the details later, but it's just one option. It's called B1. There's another option that's called B2. And he expects that option B2 will have a higher equipment cost, meaning a higher investment cost, right? But is going to provide higher revenues as well. And the business is going to be over, I guess, in 3 years when he graduates from college. And so here are the 2 cash flows. I mean, everything is summarized in a table very nicely. And in fact, I think this is also given. Like, you don't have to solve for this, right? So they're giving you the cash flows, and you see here B2 is a costlier investment. And if you compute the rates of returns, or the IRR, notice here we have a simple investment, so they're equal to each other. Or, I mean, I think in this case, as I said, it's given. It is 25% and 17.43%. So you have everything you need. And now I'm asking you to compare the 2 options. So the question is actually here. Which project would John select at a MAR of 10%? Note, of course, I mean, this is part of the question, but it's also helpful for you to check. First thing you do, check the projects individually. Are their internal rates of return both higher than the MAR? And the answer here is yes. Okay, so that's kind of a first check that you need to do, because the MAR is 10%. Both of these are higher, so we don't have to eliminate anything. Okay, but we still have to pick and choose between B1 and B2. So you look at the initial costs at time 0. This is a bigger investment, right? You're putting down $12,000. So therefore it has to be B2 minus B1. This is my third column. This is what I need to do. Okay, and the way you can check that this is, I mean, even if you forget what you need to do, make sure that what you get here is an investment. Think about it. If you do it the opposite, you're going to have a positive value here, and then you're going to have negative values likely here, right? Which doesn't make sense. We want this column to be an investment, and that's why we do the costlier one minus the less costlier option. And how do you determine costlier? Again, you just look at the initial cash flows. Just the first one. And we're going to see there are cases like if you have zeros or if you have them equal. I mean, we're going to see what we need to do in that case later. So in any case, I found B2 minus B1, so I subtracted the cash flows, right? So B2 minus B1 going in this direction, right? And that's what I have here in this column. I compute the internal rate of return on this incremental investment by solving this equation. Again, this is just the present worth is equal to 0. I find the present worth, set it equal to 0, right? And then solve for I. And if I do that, I mean, here, notice that I think they use trial and error. So they start with a guess. They do 10% at the beginning. They found that this is positive. It's not 0. So I need to increase my interest rate in order to get it closer to 0. They tried 20%. Now I have a negative value. So obviously the interest rate is somewhere in between, right? So this 15, by the way, I mean, this is not given. This is what I'm trying to find, right? So I tried 10, I tried 20. Now I can use linear interpolation like we covered before. And if I do that, I find this is the value. And for some reason, they just rounded it to 15% and they stopped there, right? And maybe they do check. No, at least not on the slides. I think maybe on the next slide. I'm not sure if they actually check if 15% will make, right, if this is the case, basically. Because you're supposed to check before you accept the solution. But let's assume they did that for now. So this is the internal rate of return for this incremental investment, this 15%. Okay, now what do I need to do? Again, I just need to look at this in relationship to the MAR. This 15%, what is my MAR? My MAR is 10%, I think. I think it's, I don't see it here. Yeah, it's 10%. So the 15% is higher than 10%. So obviously, I accept the incremental investment. Therefore, I'm justified in taking the costlier investment. Therefore, I select product B2. You can memorize it. I mean, if you do B2 minus B1 and you accept it, therefore you select product B2. Select the first one. Or you can think about it conceptually as I'm doing right now, right? And so because 15 is greater than 10%, I select product B2. Okay? Oh, this is also showing you that if you use the present worth criterion, right? So if you ignore this incremental business and you go back to chapter 5, right? Chapter 5, how do we compare two investments? Well, you just compute the present worths of those two investments. And if you do that, you get 842 for project B1 and 1718.5 for project B2. And obviously, I choose the one with the higher net present worth, which is project B2. So what we've just found using this incremental analysis and the internal rates of return is consistent with the present worth approach, which is nice. And here I'm just sort of graphing things, right? Or the book is. I wish I could draw things easily, but here's the table that we did together. And here you see the present worth plots for both options, right? So B1, B2. So B2 is this curve here. It starts from here. And B1 is this curve here. And notice, of course, that from the present worth criterion, I know that if the net present worth is negative, I will choose not to accept the project. So notice what happens here. So beyond this point, right, because this is the point at which B2 intersects the x-axis, I'm not going to choose B2. Okay? Beyond this point, I'm not going to choose B1 because here the net present worth of B1 is negative. So actually in this blue range, neither option is attractive, right? Because you're not going to choose B1, you're not going to choose B2 in this range because the net present worth of both of them are both negative. And you can see here in this, so this is the point, actually, this 15% is the point at which they intersect. I can go through like why this is the case, but I'm not sure how important this is. And also I encourage you to think about this. Like, why is the 15%? Why is the zero of the incremental investment? Right, so we found B2 minus B1. Right. Why is I star B2 minus B1? The intersection, why does it give the intersection of these two profiles? So you can think about that later. But just know that, based on what I just saw, that I'm going to select B2 in this range here. Why? Because my MAR, which was 10%, is less than this value here. So there's a lot going on in this picture, so it's a little bit complicated to explain, right? But remember, my MAR is 10%. The incremental investment had an I star of 15%. And so because of that, as long as my MAR is in this range here, less than or equal to 15%, I will accept, or I will select B2. And so that's why you see here in this range, to the left of the line that I'm drawing, you will accept B2. And then, of course, to the right of the line is the opposite, where I will select B1. Okay? So you can go through this graph just to see, or to make sure you understand what's going on here. I'm not sure how important this is, so I'll move to another example, because there's a chance, I think, that we will finish this chapter, because the rest are just examples. So you may be wondering what happens when the two initial cash flows are equal. Right, so suppose you're given two investments, C1 and C2. You need to compare them using the IRR criterion. Suppose I specify that that's how you need to compare things. Now you do what you're supposed to do. First of all, you check that these values are greater than the MAR. Once again, the MAR is at 12%. Both are greater, so both projects are profitable at 12%. Oops. So that's the first step. Second step, you look at time zero. Which one is the costlier investment? Well, they're both equal in this case, so what do I need to do? Okay, and so let's look at what we need to do in that case. Notice what it says here. When the two initial investments are equal, we're going to progress through the cash flow until we find the first difference, and then set up the increment such that the non-zero flow, the first non-zero flow, is negative. So that's a little bit of a mouthful, but let's see what happens, right? So if you subtract C1 from C2 or C2 from C1 here, you're going to get a 0, because, I mean, they're equal, right? If I go here, here I have different values, okay? Now remember, I always need my incremental investment to start with something negative. I can ignore zeros. So let's say the first one is 0. So in order to start with something negative here, notice that here in this case I need to do C1 minus C2 to get a negative value here. And so therefore I'm going to stick with doing C1 minus C2, and this is how I'm going to do it. Just because after the 0, the first difference is negative if I do C1 minus C2. If I do C2 minus C1, it becomes positive, and I don't want to do that. Yes, Abdullah?
Why do we want it to be negative? Because in the last
Because
example, it was positive.
Yes. No, see, the first one here is negative. We didn't have a 0 in this example.
Oh,
we
the
always
first
want this
criteria is negative.
The first cash flow, yes.
Oh,
the first, yeah. So why? Because we want this to be an investment, and so it has to be of the form sort of negative and then positives usually, right? And so that's why, because again, the question that we asked was looking at this as an investment. And so you see here, they're doing C1 minus C2 for this reason. And so the first one is 0, we know that. The second one, I engineered it to be negative. And then the rest I got positive values. And I got a nice simple investment. Now what do? I proceed as before. It doesn't change anything from here like to the end of the solution. right? So I set the present worth is equal to 0, right? I find the present worth, and then I solve for I, or I star. I get this value here. So you can use trial and error, you can use software, whatever, however you do it, you get 14.71%. Also notice that the increment is a simple investment. So to Mazen's question, I star in this case is equal to the internal rate of return. So you see here it says which is also an internal rate of return. So why is it simple? Notice here that this increment, I ignore zeros, remember? I have negative and then I have one sign change. So this is a simple investment. Now, since this value here is greater than my MAR is 12%. Therefore, I'm going to select the first one, which is C1. And they're also saying that if you use present worth analysis, right, you're going to get the same decision, right? You compute the present worth at the MAR of C1, which is what we did in chapter 5. You compute it at the MAR for C2. You see that you accept C1. So our decision is consistent with the present worth criterion. Here's another case. What about if you have 3 alternatives? Well, the way we do it actually is by successive examination. So you take them as pairs. And so here are the steps. So first of all, again, you need to do the checking step, right? You look at these guys here and make sure each of them individually is larger than the MAR value. So my MAR is 15%. All of these are larger, so the first check is complete. Second thing I need to do is I need to arrange them or order these investments based on their investment costs. And the way I do it is I'm going to start from the lower investment cost. Right? So the lowest one actually is D2, only $1,000. I'm going to compare that with the second lowest one, which is D1. After I do that comparison, I'm going to select one. It's kind of like tasfiyat, right? I'm going to select one, and then I'm going to use the one that I select to compare it with D3. So, I mean, you can draw the bracket here. So I'm going to do D1, D2, right? And then the winner faces D3 for the final. Okay? And you do, of course, each step, you do it exactly like we did it before. Right? I mean, I could skip this. So now let's just look at an example here. Right? So the first thing, as we said, is D2 is the lowest investment cost. Right? D1 is the second lowest. And so notice here, I need to do D1 minus D2. After picking the 2 lowest ones, I, of course, need to do the costlier one minus the less costlier one. And I see here I have a difference of $1,000. This is my cash flow. So this is for the first round. And of course, I need to proceed as before. I need to find this internal rate of return, and then I need to compare it to the MAR. So that's what they do here. The present worth is equal to 0. They tried a value of 25. They're using the trial and error approach again. They find a positive net present worth. So I need to increase I. They tried 30%. I've gone negative now. So my I is in between. I can interpolate. If I do that, I plug in the interpolation formula. I find this value here. Once again, they stopped. I'm assuming that this is accurate enough. And therefore, they just compared this internal rate of return to the MAR. Right? The MAR was 15%. This is greater than 15%. Therefore, I'm going to select the first project, which is D1. So D1 is the winner from the first round. Comparing D1 with D2, I get D1. Now, of course, I need to do D1 and D3. Draw it like this, maybe. And I need to find the overall winner. I'm actually spoiling the solution. Should have been more careful. But in any case, you do the same thing. So notice here that I picked D1 from round 1. I now put it against D3, and I repeat the process exactly the same way, right? I find that there's an additional investment of $1,000. This is my cash flow. I write down the equation. The present worth of I is equal to 0. I need to find the internal rate of return. I use trial and error. I try 6%. It's positive. I need to increase my I. I try 10%. It's negative. I interpolate, and I find that the internal rate of return is 8.85%. Notice here what happens. 8.85% is less than 15%, so it's less than the MAR. In that case, I'm not going to actually choose the first one. I'm going to choose the second one. I'm going to choose D1. Okay. So we conclude then, so I'm selecting D1 again. So just to complete the bracket now, right, D1 is the winner. Right, and then here I had, well, D1, D2. Okay, so D1 is my final choice. And that's how we do it if you had 3 alternatives. Okay, so actually we're doing great. We only have 2 more examples. And they're very quick. So I think, I mean, that's great. That makes me happy. I mean, we're finishing chapter 7. I do apologize if I went a little bit quick, but hopefully things were clear enough, especially like there are multiple examples here. I mean, I just needed to explain like 1 or 2 concepts in this lecture, and hopefully that was enough, but please ask me if something is not clear. So just to do this example, so notice here we have cost-only projects. So we don't have revenues in this case. And you've already seen this, I think, even in the midterm, right? Suppose I give you 2 options, right? The CMS and this FMS options for some type of investment. And I give you costs, right? Notice here we have an investment cost, we have total annual operating costs, and we have a salvage value. I mean, which is not really a cost, but again, sometimes we think of it as a cost. And I tell you that the firm's MAR is 15%. Which alternative should you choose? Now, we said before that if we had just, I mean, let me draw them downwards because we have costs. If our cash flows consist only of costs, we can't quite get a rate of return in that case. It's not well defined. But here, because I have 2 options, I can still find the incremental investment from these 2 options and do my analysis on that. Okay, and so let's see how this works. So here's the cash flow for the first option. There's an investment cost, there are annual operating costs at the bottom, and then there's the salvage value. Here's the cash flow for the second one, very similar but with different values. And so notice here it says, although we cannot compute the IRR for each option individually because we don't have any revenues, I mean, we do have 1 here, but like generally speaking, I mean, this is really a cost-only type thing. We can still compute it on the incremental investment. And so notice here, which one is costlier? So FMS is the costlier option. It has the bigger investment. So I'm going to do FMS minus CMS to see if the additional investment in FMS is worthwhile, right? And so if I do that, if I subtract FMS minus CMS, which is written here, this is the cash flow that I get. And notice now that this turns into a nice investment, right? An investment type structure, right? So I have an initial value put down here, which is the additional investment, the difference between these 2. And then I have some savings or some income. And now I can do my analysis as before, right? So now I can compute the internal rate of return of this incremental investment by finding the present value of this here. It turns out to be 12.43%. It's not in the slides, but I mean, you can verify that. I notice that it is less than my MAR. Therefore, because I did FMS minus CMS, and it's less than the MAR, I'm going to choose the second option in this case, which is the CMS option. And you can also do this, of course, by using the present worth criterion, right? Even if you just have costs, we've seen service projects before, right, where you only have costs and not revenues, and we dealt with that in chapter 5. So you can find the present value of this one, find the present value of this one, and just compare them, and that should give you the same answer, the same final decision. Okay, one last example. In this case, we have unequal service lives, right? And this is a case that we've seen in both chapters 5 and 6. So the quiz, by the way, should start in 5 minutes. So I mean, I'm making good time. So finish this example, and then we'll have our quiz. So here you have 2 mutually exclusive alternatives, right? But the defining feature of this example is that project B lasts only for 2 years. Project A lasts for 3 years. Again, just to check here, in this case, both our rates of return are higher than the MAR. So the first check is nice, is complete. And the question is asking you which project should you select under an infinite planning horizon, assuming you can repeat the projects as many times as you would like with the same costs and benefits using this IRR criterion. Okay. Now, why am I doing this example? Well, how did we solve this before in chapter 5 and chapter 6? Generally speaking, we find the least common multiple, if you guys remember, of 2 and 3, right, which is 6. And then I repeat project A 2 times to get to 6 because, 3. And I repeat project B 3 times. Now, if I do that, notice what happens. So this is what I'm doing here, project A, project B. So I'm going up to 6 years. So I start with the first cycle, everything's good. The second cycle, the second cycle starts when the first cycle ends. And so notice here, I'm putting down the investment cost again at time period 3. Now what's going to happen? This is going to result in the value at time period 3 being negative. So I've started off with a simple investment. If you look at it here, this looks like a simple investment. Negative and then all the way positive. But because of this, because I'm stitching the cycles together, now I have a negative here. So I have negative, positive, positive, negative, right? Positive, positive, positive. So there's one sign change at the beginning, another sign change here, and then a third sign change here. So now this turned into a non-simple investment. And same thing happens for B, right? If you look at B, the same exact thing happens, right? You get 2 negatives here, which kind of destroy our simple investment. And so in this case, actually, we may want to abandon the use of IRR and go back to the present worth criterion. Why? Because we have non-simple investments. And so I go back to chapter 5. So I compute the present value for this cash flow. I compute the present worth for this cash flow. And I just compare them together. Here, actually, well, they did it for the incremental one. I mean, you could do that. I don't see why you need to do that. You can just do them individually on the 2 projects and select the higher one. But you can see if they give you the same result, and they should. All right. I guess maybe in a way this gives you a different perspective also on the present worth, right? So if you do it using the increments, so if you still do the incremental difference between B and A, so B is the cost of investment. That's why we do B minus A. If you compute the present value of this, check to see if it's positive, it kind of gives you a different perspective. Like, again, the question that is posed by using this incremental thing is the additional investment in B justified? And therefore, if it is justified, you should go with project B. But either way, I mean, you could do it individually, you could do it on the increment, it's up to you. Finally, I just want to point out example 7.10 in your textbook. It does a similar thing as this one with unequal service lives. But actually, the resulting incremental cash flow, even though it's non-simple, it does have a unique rate of return, which I told you is possible. Okay? So just because it's non-simple does not mean it does not have a unique rate of return. It can have a unique rate of return, and it's always good to verify that. So I'll leave this example for you to just check. And that finishes chapter 7, and just in time for the quiz. So please ask me if you have questions. I'm sorry if I went a little bit fast, but hopefully, I mean, the concept was very clear, which we spent most of our time on, and then the rest were just examples. But please ask me questions. The quiz should be live actually now, so good luck. I'll put up a formula sheet for the quiz in the meantime.